Hi everyone. Today we're going to be studying tides. So, if you do not yet have these materials, your science notebook, a pencil, and some color pencils, I want you to pause the video and then when you're ready to go, come back and we'll get started. So, let's go ahead and jump right in. I want to begin with another bell ringer. And so, I want you to number in the margin of your notebook 1 to 7, and then I want you to try to match each letter here from this list of definitions. Let's try to match each letter with that vocabulary word. Please remember, these are most likely things that you'll see on a quiz from me. So if you'll pause the video and go ahead and try matching 1 through 7, restart the video whenever you finish. Let's go over these bell ringer answers. So first off, 1 through 5, crescent, gibbous, quarter, full, and new. Those are all those basic shapes of the moon. So a crescent moon it describes any phase where less than half of the moon appears to be lit, where a gibbous moon, on the other hand, describes all the phases where more than half of the moon appears to be lit. A quarter describes phases. That's a shape where exactly half of the moon appears to be lit. Remember, we'd have 2 quarters, first and last, or first and third. Those are only 2 nights out of that 30-day cycle. And then, of course, we have full, where all of the moon appears to be lit, and new, where none of the moon appears to be lit. So that leaves us with 6 and 7, which is waxing versus waning. Waxing phases are where the lit part of the moon appears to be increasing or getting bigger each night. So if we start at a full moon, we know that gradually, as the moon changes its position, more and more of it appears to be lit from Earth. So as we are moving from, over that 14-day period or so, moving from new moon all the way to full moon, all of those phases are waxing. Now, when we reach full moon and we're going back toward new moon to complete that cycle, those are going to be our waning phases. So those are the phases where the lit part of the moon appears to be decreasing, meaning getting smaller each night. So keep those key vocabulary words in mind. So you may be asking yourself, how does that have to do with tides? So let's look at our objectives today. We're going to be looking at what tides are. Some of you may know, some of you may not, and really where they occur at. We want to be able to understand and explain what causes tides to happen. You're going to need to be able to understand a diagram of the Earth, the moon, there's the moon, and tidal bulges. You're going to need to be able to describe how many low and high tides occur daily, and list and explain the causes of special tides. So each month we have some special tides, and those are spring and neap tides. Let's go. So tides are really pretty simple, and some of you have experienced these before. I know we live in the mountains, but if you've ever visited the coast or the beach, you know that the water in the ocean, daily it will rise and it will fall. And that's what a tide is. If you look at the picture, this is a place called the Bay of Fundy, and these pictures are taken just a few hours apart. So we see a pier with some boats at it, and we can see there at low tide, there's no water anywhere. But if we wait a few hours and maybe 6 hours later, we're going to see high tide. And as far as you can see in this Bay of Fundy, the water has made a huge increase. It's risen all over the place. So that's what we're talking about when we talk about tides. We're talking about the water in the ocean that rises and falls. And it just happens every day. These are natural cycles. And a low tide really is just the lowest water level reached by what we call a falling tide, whereas a high tide, that's going to be the highest water level. So some vocabulary that actually makes sense. So tides, can make a huge difference, of course, for the things and the people that live nearby the ocean and on those coastlines. I want to take a look at this. This is called a tide table, and this shows us over a 24-hour period, this is 24 hours, what's going to happen. So here our table starts out with a low tide, and you can see that this on our graph shows us the lowest water level, and then slowly but surely there's a gradual increase. The water level just like in our last picture, comes up to a maximum. Okay, so that maximum is going to be our high tide, and it will stay there, but then it will slowly begin, the water level will begin to fall again. Begin to fall until 6 hours later. Please notice that there's about 6 hours in between. So 0 hours, 6 hours, it's halfway between the 4 and the 8. We go down here to 12 hours, which is 6 hours later, we have another low tide, and then we're going to go back. It's going to begin increasing again once we reach that low tide to a high tide. Notice that's 6 hours later. This is hour 18, and then goes back down again to a low tide. And so this is the natural cycle. We go from a low tide to a high tide to a low tide to a high tide to a low tide. And most places, it's pretty safe to say that most places along the coast experience 2 high tides and 2 low tides every day. So over a 24-hour period, you're going to see 2 high tides and 2 low tides. And so that's important to keep in mind. That's one of our objectives. So this might be a little bit of a mystery. I've given you some context clues already. I've given you some hints, I suppose, in our objectives. But I want you to stop and think for a minute. What in the world could cause such an increase or decrease in the water level? I mean, if you really think about it, that's really strange. So I want you to pause the video. You don't have to write it down, but I want you to think about an answer. Once you have what you think causes the tides in your head, I want you to restart the video again. So what does cause the tides? So this diagram is probably the most helpful diagram that I can share with you to have you think about what causes tides. So really, tides are mostly going to be caused by our moon. Okay? So our moon, like every other object in the universe, has gravity. Gravity is really a pulling force. Gravity is one object pulling on another object. And so let's pay particular attention to right here. So the side of the moon, our moon, we said, was about 330,000 miles away, but its gravity pulls on Earth. And so the moon's gravity actually pulls on this water in the ocean, which is a liquid, and it's able to pull that water away from Earth. It actually creates what's called a tidal bulge. So the moon pulling on the water, pulling on Earth, and it pulls that water out and it makes that water bulge. So here, if you happen to be at this place on Earth, right here, you would be experiencing a high tide because the side of Earth would be faced or would be closest to the moon, and it would be under the influence of the moon's gravity, which would be pulling on that water. Now, when we have these high tides, because the fluid in the water in the ocean, it's a fluid, which means it can flow. So if we create a high tide here, it necessarily creates low tides here and here. So if at this point in time, high tide is here, that means that here and here, we're going to have 2 low tides. Okay, so we're going to have 2 low tides here and here that are really going to be caused also by the moon's gravity by this high tide. So that means, I want you to think about the fact that the Earth is always rotating on its axis. So if the moon is at this position in its orbit, eventually if you're here at low tide, 6 hours later, because remember it's a 24-hour period for the for the Earth's rotation. When you're here, 6 hours later, you're going to be here, and you're going to be at a high tide. 6 hours later, you're going to rotate to here. As Earth keeps spinning on its axis, and you're going to experience another low tide. And 6 hours later, you'll have rotated to here, and you will have another high tide. And this cycle just keeps continuing. Now, I want to look, this is the high tide, but I want you to notice that there's a high tide on this side of the Earth as well. And let me just tell you, I agree, it's strange. I'm going to briefly explain why we have, this should make sense. The moon's gravity pulling on the water in the ocean should make sense because the moon's on this side, gravity's stronger here. It should be able to make a bulge. It should be able to pull that water away and give you a high tide. But over here, you're actually on the side that is farthest from the moon. This is a little bit of a struggle, and so I'm gonna go ahead and try to explain this. I will not ask you to understand why we have a high tide on this on this side. This is not something I would ever ask you in a quiz. Before we move on though, I do want you to pause the video and I want you to draw this diagram in your science notebook. I don't need you to write these things down unless you think you need them. If you think you need them, then please do. If you think you can remember what I said, this diagram should be enough. Yes, it needs to be in color. Go ahead and pause your video. All right, so let's look at this Farside tide, and I don't want to take a lot of time on this. So the Farside tide, which is the low high tide, which is on the opposite side of the Earth from the Moon, is actually caused by Earth's rotation. So Earth's rotation actually causes one of these high tides. If you have ever taken a bucket, like a 5-gallon bucket with a handle on it, full of water, no, with a little bit of water in it, and you start spinning your arm over your head, and you spin it and spin it. You may have noticed that the water, you create like this centrifugal force on the water, and the water will actually stay in the bucket. Well, that's kind of what's happening here. This low high tide away from the moon, this is actually caused by the rotation of Earth. Earth's spin actually bulges the water out on the opposite side. It doesn't bulge out the water in the ocean as much as the gravity of the moon, but it does cause this opposite high tide. So it's rotational force and the inertia at this point over here, the inertia of the water, the motion of the water, the forces on it, are more than the gravitational pull of the moon. So we do end up with a high tide, a far side high tide that is a lower high tide on the opposite side of Earth. You don't really need to know that, but I know some of you were thinking, well, that doesn't make any sense. Hopefully now it does. Let's talk about these special tides. So every month we have two special tides. Actually, we'll have two spring tides. We're going to have two neap tides. Okay, so spring tides are going to be caused, well, let's talk about what they are first. Spring tides are tides each month that have the highest high tides and the lowest low tides. So these are like tides on steroids. So if it's a high tide, they are going to be the highest of the high tides we get through an entire cycle of the moon traveling around the Earth. And the low tides are also going to be the lowest low tides. So we get big changes in water level. And we'll use this diagram to understand what's happening. So for a spring tide, I want you to note the position here of these three things, sun, earth, and moon. Okay? So note here that we have Earth. We see our tidal bulge here. This is where we would expect to see the moon, right? The moon's gravity bulging or pulling that water away from Earth. But I want you to notice out here we also have the sun. Note the location of the sun. It is true that the gravity of the sun, because the sun is enormous, even though it's 93 million miles away, the gravity of the sun also pulls on the water and Earth. So when we get the sun and moon aligned like this, they pull together. So a spring tide, these high tides, are caused really by the sun and moon being in this alignment and pulling together. Now this is only going to happen we can see here, so the lit port, this is at a new moon, right? Because if you're here on Earth, you can only see the half of the moon that is, excuse me, you can only see the half of the moon that is dark. And it's also going to happen over here. So as the moon continues and it goes another 14 days through its cycle, over here, this is at a full moon. So at new moon and full moon, we're going to have these very high tides, and these are caused by the sun and moon being aligned and pulling together. So let's look at this. This is a spring tide. Let's look at a neap tide. So these are tides that have the lowest high tides and the highest low tides. So in other words, we get the smallest changes in water level. So if we look here, we can see that in our diagram, here's our tidal bulge. It's where we would expect it. Remember, the moon is most important. It's the moon's gravity that mostly causes tides, not the sun's gravity, although the sun can have a small effect. So we can see the tidal bulge that's up here. So when we're at third quarter and at first quarter, we're going to have a tidal bulge here, but the sun is actually pulling on, and we call this a solar tide. It's not important that you remember that word, but we can see that the sun is actually creating a bulge of its own. And because when we have this alignment, because we have the sun pulling in this direction and the moon pulling in this direction, we end up with these smaller changes in water level. We end up with neap tides, and really these are just caused by what it looks like. the moon and the sun being out of alignment. And their gravity is actually working against each other, which is going to be these smaller changes. Remember, these neap tides can only happen at first and third quarter moon phases. So spring tides, these are the high, big water changes. Highest high tides, lowest low tides. Those are caused by perfect alignment of the sun and moon at new and full, and that's when they pull together. The neap tide, on the other hand, this is going to be when the sun and the moon don't pull together. They actually pull against each other, which creates a smaller overall change in your water level. So if you live at the coast, the tides turn out to be something that you pay attention to. Most people who live on the coast would pay attention. So what I've done is I've just tried to show you what's called a tide chart. So if you live at the coast, you'll keep an eye on the tides. And we can see here we got a high tide, 6 hours later a low tide, high tide, low tide, and then so really though, we have a lot of information. I want you to note that this is put out before January. This is for January 2014. This is for someplace in Mexico. It says San Felipe. And I want you to notice that we have an entire month worth of tidal predictions. So the thing that I want you to keep in mind, even I don't need you to know how to read a tidal chart, but I need you to keep in mind that the tides are very predictable. We understand the motions of the sun and the earth and the moon, and we're able to predict those tides. So a tidal chart is going to have a lot of information. It's going to tell us where it's from, where that tidal chart is for. It's going to give us the exact time. So if we look, it's going to tell us the exact times of these, excuse me, of these high and low tides, and that's going to be these numbers down here. It's going to give us our maximum tide height, right? So these are all heights in here. So we have this, we do have this line graph to help us, but we also have these tidal heights along this line. And it's also going to show us these important moon phases. These important moon phases are going to help us find where the spring and the neap tides are. So this right here, this looks like it's showing us on the first. This is a new moon, so I know a new moon. Oh yeah, that means that the sun and the moon are pulling together. So that's going to be a spring tide. If we go down, about 6 or 7 days later, we're going to find a quarter moon. So a quarter moon, that means the sun and moon aren't pulling together. So that's going to be a neap tide. And then we can find our full moon here. So that's a spring tide because once again, pulling together. And then here we have a third quarter moon, which is our last quarter moon, which means they're pulling against each other. So that's going to be a neap tide, smaller. And then we'll go through that cycle again. So a tidal chart is really just a fancy way for you to keep track of what's going on with the water levels. And the thing I need you to remember is tides are predictable. All right, so let's do a quick assignment. Not a lot of things that we need to get down for vocabulary after this lesson. I do want you to get a basic definition of tides. You're going to need to, of course, remember that we have 2 high tides and 2 low tides every day. And I need you to write about spring tides and neap tides in your notebook. Okay, so I need you to write about spring tides and neap tides in your notebook. Remember, you'll be able to use these notes on your quizzes. All right. One of the best things about studying the moon is it's something you can actually see. So here's our Just for Fun lab for tonight, and we'll continue this for several nights. Tonight, I want you to step outside, and I want you to look at the moon. Now, there could be clouds. I get that. So you may have to wait an hour or two and try to step back outside. But I want you to try to make a moon observation tonight. If your family's got binoculars, that's enough. You do not need a fancy telescope. Ask first and see if you can borrow them. But take some time, get comfortable, and I want you to take a look at the moon. I want you to look, see if you can find some surface features like the Maria and the Highlands. See if you can spot any craters. And I do want you to draw a table in your science notebook to keep track of the moon phases. Okay? So to do that, you may want to use something like this. This one's pretty fancy. For your observation, any night that you make a moon observation, I want you to put down the date, and I want you to put down the time that you observed it, and I want you to try to draw the moon phase. So in other words, you would just shade the part that you can't see. Okay, so you would need to shade the part. This is a pretty good moon observation chart that you are welcome to copy into your notebook, or you're also welcome, since this is just for fun, just to draw what you see, put a date and time with it each night. Okay? So if you have some difficulty, if you go out and it's cloudy tonight, then I want you to try this observation a couple hours later, maybe even wait till tomorrow night. I think that does it, gang. So for now, until next time, stay curious.